There is no one online, no? Yeah. ஒரு நிமிஷம் புடி சிரிச்சிட்டே இரு பாப்பா. இந்த ஒரு நிமிஷம் பிடிச்சி இதை இப்படி பிடிச்சிக்கோங்க. Show me the positive and the negative. வேல்யூ ஏதாவது தெரியுதா? இல்லை அது ரெண்டும் கனெக்ட் பண்ணிவி. லைக் இன்னும் I think one of the cells is not working. ஒரு இது பேட்டரி மட்டும் காட்டு. இதுல வேல்யூ இருக்குல்ல 1.52 அதை காட்டு. ஒன் 1.619 இருக்கு. ஸோ ரெண்டும் ஆட் ஆகணும் ஆக்சுவலி. இந்த ப்ராப்ளம் இருக்கு. சார் பார்க்குறேன். Okay. We shall get started. Right. So we'll start with the next topic. Write down the heading. The next topic is going to be cells in series. Right. Okay. So let me explain what that means. See, first point that we need to understand is whenever we see the word series, right? So we have seen what are capacitors in series, what are resistors in series, right? So whenever we see the word series, something is common and the other parameter will be changing. So there are two parameters that will always decide whether it is a series connection or a parallel connection, out of which one is current and the second is voltage. See, the logic is very simple, okay? You need not memorize anything. When I say capacitors are in series, for capacitors, we don't define current. Rather, we define charge. So, if the charge across the capacitors is same, right? Basically, in series connection, what will happen is the charge across each capacitor will be the same, but the potential will get divided. Whereas in parallel, it will be the reverse. So you take the same logic and apply it to resistors as well, right? When do we say the resistors are in series? When the current flowing through every resistor is going to be the same and the potential is getting divided, right? Same is the concept with cells also. So the only difference is there we consider it to be a passive element. When we talk about a resistor or a capacitor, they are passive elements. What do I mean by passive elements? They are the ones which take energy from the outside source. So passive elements are those elements which absorb energy or which take energy from external source. Whereas active elements are the ones which are able to supply energy to the system. So obviously, what is going to be an active element? A cell, a battery is an active element. Similarly, if you take a charged capacitor, that also acts as an active element. Are you able to understand? So if you remember, we solved one of the problems in the previous chapter. There was a capacitor of 900 picofarad which was completely charged. It is connected to another 900 picofarad which was uncharged. So the one which was charged can be treated as an active element, and the one which is uncharged can be treated as a passive element. So same logic here. Okay. So what we are going to do is we'll understand what do we mean by cells in series. So one thing that we need to understand is when I talk about cells in series, the same logic is applicable that the current across both the cells is going to be same. But there is one point I would like to stress upon. See, this point I've already mentioned, but I'm repeating it. Listen, positive terminal, negative terminal. You have a negative and a positive terminal. So if I take the positive of this and connect it to the negative of this like this, then what will happen is this potential and this potential will get added. Right. So this is a 1.5 volt battery. This is also a 1.5 volt battery. They get added. Right. As a result of which the combination acts as a 3 volt battery with whatever is the internal resistance that we'll calculate and see. As of now, let's take the ideal situation into consideration. So this can be called as series connection. At the same time, this can also be called as series connection. That is, you connect the positive to the positive, right? You connect them in such a way that the current through both is going to be the same. Then still you can call it as series connection. Only difference is in this type of connection, when a positive is connected to the negative, they support each other. Whereas when the positive and the positive are connected across each other, they oppose each other. Are you able to understand? So having this in mind, see, if I take one cell with internal resistance R1 and EMF E1, similarly, if I take another cell with EMF E2 and internal resistance R2, right, I can say that these two are connected in series. So what is the first point that needs to come to our mind whenever we see series connection? It is the current. So the current that is flowing through the device is going to be the same. Meaning, if this is supplying current I1, I'm taking the discharge condition. If E1 is supplying current I1 and E2 is supplying current I2, that I1 and I2 will get added to give a common current of I. So what I'm going to do here is I will say the current supplied or the current flowing through the system is I. Am I clear with this? Right. So my job is I need to understand how much is the battery's EMF value that I need to replace with so that it does the same job done by these. That is the equivalent EMF. Similarly, I need to find out how much is the equivalent internal resistance the new cell will have. Meaning, if I replace this E1 and E2, I will write another cell whose EMF is E equivalent. Okay. And the internal resistance will be R equivalent. And it is going to be a single cell. But a point to be noted here is the single cell will supply the same effective current I. So this is the initial circuit and this is the final circuit. This is the converted circuit. Okay. What I'm going to do is I'm going to deal both of them parallelly. Observe. So if I take this point to be A, if I take this point to be B and this point to be C, okay. Now, I can say the equivalent of this is happening between the points A and C. The intermediate point is gone. Meaning, between the points A and C, I can either connect two cells with two internal resistance and two EMFs, or I'll replace it with one with equivalent value and equivalent internal resistance. Am I clear with this? Now, what I will do is, I'll apply the relation for terminal potential difference, EMF and internal resistance across this one first. So across the first cell, can I say VA minus VB, which is the terminal potential, is equal to E1 minus I into R1 because it is a discharging condition, right? So current is away from the positive terminal, so it is getting discharged. What about VB minus VC? This will be equal to E2 minus I into R2. Makes sense, right? But my interest is between the points A and C, right? So these two have come from this circuit. Whereas if I write VA minus VC here, what will I write? I will write it as E equivalent minus I into R equivalent. Okay. So this is from the first, this is from the second. Have this in your mind. Now what I'll do is I need VA minus VC. So in this, I will add these two equations so that VB gets cancelled out. When I do that, I'll have VA minus VC is equal to E1 and E2 get added. So E1 plus E2 minus I into R1 plus R2. Let me call this as equation number 1 and let me call this as equation number 2. If you observe in 1 and 2, the left hand sides are equal, so the right hand side should be equal. If that is the case, E equivalent minus I into R equivalent. I'm writing this expression first is equal to E1 plus E2 minus I into R1 plus R2. So if you do the comparison on both the sides, you can say that the E equivalent value is equal to E1 plus E2 and R equivalent value is equal to R1 plus R2. This is basically understood because if you forget about the cells, if the resistors are in series, what will happen to them? They get added. No, the same thing is happening. So with cell alone, you need to be careful. So what is happening here is the equivalent EMF in this scenario is E1 plus E2. Am I clear with this? So this is the equivalent EMF and there is the equivalent resistance. So make a note of this. Let me know once this is done. Done? Okay. See, the next point that we are supposed to notice, suppose the cells were connected like this. If this is R1, this is R2, if this is E1, this is E2. Now what will happen is, in the previous scenario, we wrote the value of I as the effective current because E1 is also supplying current, E2 is also supplying current. Whereas in this case, the same thing will happen. E1 will supply current in the leftward direction and E2 will supply the current in the rightward direction. So what will happen is they both will get cancelled out. Right. So I cannot say completely cancelled out, they both will get subtracted, to put it simple. Right. So when that is a scenario, in this case, the value of E equivalent will be equal to the difference of E1 and E2. When I say difference, I need to take the first value to be the one which is having greater value. Suppose this is 5 and this is 3. Here the net EMF will be how much? It will be 2 volt. So it is basically taking place because it is E1 minus E2, whereas the value of R equivalent is still going to be R1 plus R. Are you able to understand this? Right. So resistance value will still get added, but the EMF will get subtracted. So that is why whenever you look at a problem where there is a series connection, you need to have a clear check on how the terminals are connected. So this we call it as terminal connection. Terminal connection. So if the terminals are connected in such a way that the negative terminal of the first is connected to the positive of the second, then they get added. If like terminals are connected together, they get subtracted. So I use the word like, I never told positive, positive or negative, negative. It can be in any way. Is the point clear? So if I extend this to N cells, right? If there are N cells which are connected like this, so if I take this to be R1, R2, so on till Rn, and if I take this to be E1, E2, so on till En, then the net EMF is going to be E1 plus E2 plus so on till En, and R equivalent will be R1 plus R2 plus so on till Rn. Is that point clear? So this is what happens, right? I hope it is clear. Shall I proceed? So listen. Done? So listen. we will see a problem that is based on cells in series. So from the given circuit, first part is we need to find the equivalent EMF of the combination. Second is we need to find the equivalent internal resistance. Third is we need to find the total current. And the fourth is potential difference across the external resistance. Right? So it is very simple. Observe. The first question is equivalent EMF of the combination. If you observe, all the cells are connected in such a way that the negative terminal of the first is connected to the positive of the second. So in this case, the EMFs will get added. So you have 4 9-volt batteries, right? So what is going to be the effective EMF? It is going to be 36 volt. Now what about the internal resistance? So internal resistance, irrespective of how they are connected, it will always get added. So each internal resistance is 0.1. So it will become 0.4 ohm, right? So we need to find the total current. For that, what I'll do is I'll redraw the circuit. Observe. So what I can do is I can replace these 4 cells with one cell of 36 volt and of internal resistance 0.4 ohm, which is connected across an external resistor of 10 ohm. Right? That is how the circuit can be redrawn. So what is our objective? We need to find the total current that is flowing through the circuit. So to find the current, what we will do is we will treat this internal resistor as external resistor and tell me how is this 0.4 and 10 connected. They are connected in series. So how will the equivalent circuit for this look like? There is a 36 volt battery, because a series of cells is basically a battery, right? So there will be a 36 volt battery which is connected across a resistor of 10 plus 0.4, which is going to be 10.4. Am I right? Now see, what is going to be the current? I is equal to V by R. So V is 36, R is 10.4. So on solving this, you will get the value of current flowing through the circuit, right? And the last part is potential difference across the external resistance. So potential difference across the external resistance is the same as the terminal potential between the cells, right? So what is going to be the terminal potential here? If I take this to be AB, VA minus VB is the same as VC minus VD. So VA minus VB, what is the formula that we can apply? VA minus VB is equal to the cell is getting discharged. So it will be E minus I into R. E is how much? 36 minus I is 36 divided by 10.4 into R is 0.4. So on solving this, you will be able to find the terminal potential difference as well as the potential difference across the external resistance. Is that clear? So this is how the problems on series and cells will be asked. Sorry, cells and series will be asked. Okay. Make a note of this. Can I proceed? Shall I proceed? So the next topic that we'll see is cells in parallel. Right? So when can you say that the cells are connected in parallel? Whenever you see this parallel connection, right, what comes to your mind? It is the voltage that is the same. That is the potential drop across everything will be the same. And what happens to the current? Current gets divided. Right? The same logic is applicable even for cells. So how is it going to look like? If I take the cell and connect it across another cell like this, and I take a third cell and connect it in this way. So if I take this to be R1, R2, and R3, across this combination, let's say there is an external resistor that is connected. Now, we'll not take the external resistance into consideration, but we will try to understand how the equivalent value works. So if I take this to be E1, if I take this to be E2, and this to be E3, let's say the first cell is supplying current I1, the second cell is supplying current I2, and the third cell is supplying current I3, right? So if I take this to be AB, this is CD, and if I take this to be E and F, right? Now, the potential drop across AB will be the same as the potential drop across BD, and will be the same as the potential drop across EF, right? So, VA minus VB is how much? It is going to be E1 minus I1 R1. Am I right? So this VA minus VB, I'll call it as V. Right? So I'll call it as V. Okay. Let's say it like that. Then what is going to be the value of I1? So observe, I1 R1 will go to the other side, V will come to the left hand side. So what will be the value of I1? I1 will be E1 minus V divided by R1. So just to explain it again, observe what is happening is, it is E1 minus V is equal to I1 R1. Am I right? So R1 will come to the denominator. This is going to be the value. So let me call this as the first expression. Similarly, what is VA minus VB here? Sorry, correction. What will be the value of VC minus VD here? VC minus VD is equal to E2 minus I2 R2. So this will be equal to E2 minus I2 R2. But what I'll do is I'll call VC minus VD also as V, because they both are same. So when that is a scenario, if you write it in the similar format, all that will change is 1 will become 2. So I2 will be equal to E2 minus V divided by R2. Let me call this as 2. Now what about the third one? For VE minus VF, you will again have E3 minus I3 R3, which I will call it as V, which implies I3 will be equal to E3 minus V divided by R3. Let me call it as 3. So what is that we have obtained is we found the value of I1, I2 and I3 because the current gets divided. But how are they getting divided? It gets divided in such a way that the sum of these three values will be equal to the total current that is being supplied by the system. So all that I need to do here is similar to the case of cells in series, I will replace these three cells with one cell for which the equivalent EMF we'll call it as E equivalent and R will be called as R equivalent. So how is the new circuit going to look like? It will be something like this. So I can replace all the three with one cell whose EMF is E equivalent and whose resistance is R equivalent, and still the external resistor is going to be capital R. But the only difference is instead of I1, I2, I3, see I1, I2, I3, everything added together, let me say that the current is coming out to be I. Okay. Now, this cell will supply the total current I. Am I right? So what is going to be the relation here? If I take this point to be G and H, remember VG minus VH is also V only, right? So what is VG minus VH? It is going to be E equivalent minus I into R equivalent. So what will be the value of I? I will be equal to VG minus VH, I'll call it as V again. So I will be equal to E equivalent minus V divided by R equivalent, which I'll call it as 4. So the point that we need to remember here is I is the sum of I1, I2 and I3, right? So I is equal to I1 plus I2 plus I3. So what is the value of I? It is E equivalent. I'm splitting the denominator to each term. E equivalent divided by R equivalent minus V into 1 divided by R equivalent. I'll tell you why I wrote it like. Okay. This will be equal to, what is the value of I1? E1 minus V by R1. I2 is E2 minus V by R2. I3 is E3 minus V by R3. So you can remember the pattern. So what is going to happen? I1 will be E1 minus V divided by R1. And here it will be E2 minus V divided by R2. Plus here it will be E3 minus V divided by R3. So you can collect E1 by R1, E2 by R2 and E3 by R3. You will write it as E1 by R1 plus E2 by R2 plus E3 by R3 minus V into 1 by R1 plus 1 by R2 plus 1 by R3. If you do a comparative study on both the sides, right, what do you have on the left hand side? I'll write it again. E equivalent by R equivalent minus V into 1 divided by R equivalent. If you do the comparative study on both the sides, you will get E equivalent by R equivalent is equal to this value, which is E1 by R1 plus E2 by R2 plus E3 by R3, right? And what is 1 by R equivalent? 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So it is understood that if there are n cells that are connected in parallel, it will be E1 by R1 plus E2 by R2 plus E3 by R3, so on till En by Rn. And 1 by R equivalent will be 1 by R1 plus 1 by R2 till 1 by Rn. So that is known, right? So this is how the cells that are connected in parallel will work. So please make a note of it. Done? Shall we see a problem based on this? Let's see. So we'll see a problem that is based on cells in parallel. Okay. So from the given circuit, find the equivalent EMF, equivalent internal resistance, total current, potential difference across each cell, and current from each cell. Okay. So what is going to be the equivalent EMF in this scenario? It is very simple, right? We know that E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2 plus E3 by R3 plus E4 by R4 in this scenario. So E equivalent divided by R equivalent will be equal to, if you observe, E1 and R1 are the same for everything. So E1 is 5, E and R are same, 5 divided by 0.5, which is going to give you 10, right? So 10, 10, 10 and 10, you will get 40 here. This is the value for E1 by R1 till E4 by R4. Clear with this? But when you need to find the equivalent EMF, the first thing that you always need to find is the internal resistance, because this formula requires internal resistance as well. So what is the value of equivalent internal resistance? What is 1 by R equivalent? 1 by R equivalent will be equal to 1 by 0.5 plus 1 by 0.5 plus 1 by 0.5 plus 1 by 0.5. 1 by 0.5 is basically 2. 2 into 4 is going to be 8. So 1 by R equivalent is going to be 8. R equivalent will be equal to 1 by 8 ohm. So this is what we need to understand. So E equivalent will be equal to 40 into R equivalent, which is going to be 1 by 8, and the answer will be 5 volt. So if you replace every source with one source, its equivalent EMF is still going to be 5, whereas its internal resistance will be 1 by 8. So we solved the first and the second part, right? Now, we need to find the total current that is flowing through the circuit. So how do I find the total current? For that, what I can do is, I'll replace everything with one cell. I'll replace everything with one cell whose value is going to be 5 volt. And what is going to be the internal resistance? 1 by 8, which is connected across 10 ohm resistor. So this 10 and 1.8, they both are in, 10 and 1 by 8, they both are in series. So this circuit will look like a 5 volt battery is connected across 10 plus 1 by 8, which is going to be 81 by 8. So V is equal to IR. So I is equal to 5 divided by R is 81 by 8. It will be 40 divided by 81. So the total current through the circuit is 40 divided by 81 ampere. 1 minute, 1 minute. So what is the potential difference across each cell? What is the potential difference across each cell? Okay. So first you copy this, and I'll tell you. Done? So if you see, they're asking potential difference across each cell, but for you to find the potential difference, you need the current across each cell. Because what is the relation? V is equal to E minus IR, right? So what is the current that is going to be from each cell? Observe, it is very simple. When the total current supplied by the system is 40 divided by 81, everything is identical. So what is going to be the current through each? So the current through each will be equal to 1/4 of 40 by 81, which is going to be 10 divided by 81 ampere. Is that point clear? That is going to be 10 divided by 81. Now, what is going to be the potential difference across each? So, potential difference across each is equal to E minus I into R. What is the value of E? It is 5 minus I is 10 divided by 81 into R is how much? 0.5, which is going to be half. This and this will get cancelled. So 81 minus 1. So if I take this 5 outside, I'll get 80 divided by 81. So it will be 400 divided by 81 volt. It will be 400 divided by 81. If you observe, that value will be less than 5. Right? Done? Okay. So this is a small concept. Okay, there are two more important concepts left out. One is electrical power and the second is Wheatstone bridge. Okay. So now we will discuss about what is electrical power, right? You all know what is power already, right? Power is the rate at which work is being done, right? So when you talk about electrical power, you can say it like this. It refers to the rate at which electrical energy is transferred or converted. Okay. So we make use of electrical energy to run certain devices. For example, if you look at this fan, right? This fan, what is happening? Electrical energy is getting converted to mechanical energy, right? It is happening at a certain rate, right? Similarly, when you talk about a light, what is happening? The electrical energy is getting converted into light or heat, right? Both are happening actually, right? So this is the basic definition. Having said this, if I try to write the mathematical definition for power, it is the rate at which work is done. It is amount of work done per unit time, right? Whereas in terms of electrical system, we know that the work done will get stored in the form of electrostatic potential energy. So can I write this as V into Q, the whole divided by T, right? So work, I'll write it as V into Q divided by T, because U is equal to QV, if you recollect. So what is Q divided by T? It is electrical current. So this will give you the value as V into I. So that is why electrical power in terms of mathematics can be defined as product of V and I. It is a product of electrostatic potential. Sorry, it is a product of the potential difference and the electrical current that is flowing through the device. Am I clear with this? Right. So the next question is, what is going to be the unit used for it? So the unit is still going to be watt, which is represented by the symbol capital W, right? Now, so when I say P is equal to V into I, using Ohm's law, if I write V is equal to IR, what will we get here? This can also be written as I square R, or if I write I is equal to V by R, then you will get V square by R. So these are all the mathematical expressions for electrical power. Okay. So make a note of this. So that's it. Right, as I told you, each one will be the only part of the result. Listen to this one update. See, 21st, I might not be there. That is next Wednesday. Okay. But that day, what I'll do is you will be having a test in this chapter, only derivations. Only the derivations and the concepts part, not the problems. Okay. So even if I ask problems, the way you have solved it, those problems will be asked. Okay. So I want you all to be prepared on that day. By Monday, I'll be completing it, but before that, Wheatstone Bridge is already there in the pre-recorded videos. Okay. So I don't have time for me to go through that and come so that Monday I'll concentrate on problems. Meter bridge alone I'll check. If I'm not wrong, that is editor. If it's not, I'll teach for us. We'll do some problems based on the chapter. Here, so Wheatstone bridge alone, we go through the concepts. So that's it for today. We'll wind up. ஆமாப்பா இப்போ நான் கிளாஸ்ல இருக்கேன் 7 ஆயிடும் 7:50 ஓகே ஓகே நோ ப்ராப்ளம் நம்ம வந்து இது ஒரு ஜூம் மீட்டிங் வச்சுக்கலாம் நெக்ஸ்ட் ஓகே 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 பட் அதுதான் இப்போ கொஞ்சம் கஷ்டம் அதுதான் நைட் ஓகே